Today we will look at a new type of function. They're called piecewise functions, and the best way to understand them is to look at them graphically. If you look at this kind of graph, you might think that there are two functions depicted here, not just one, because obviously this follows a certain rule and this follows another rule. But if we say that this is a piecewise function, then I'm saying that we have one function that describes both of those. And it's obvious that we have a certain rule that applies for x between -6 and 1, and another rule that applies from 1 to 10. Once we establish that, and we accept the fact that this is one function, we will look at it graphically and then we'll discuss it algebraically. But first of all, let's make sure that this is a function because it passes the vertical line test. And here, there is only one value of f of 1, because for this part this is an empty circle and this is a full circle. Having established that, we may ask why are those functions necessary? We will be discussing that in class, but for the time being, let's say that those functions are useful when applying in real life to income tax, for example, where the tax depends on the income that the person receives, or on calculating when calculating electricity rates, when there are different rates for different consumption levels. Anyway, at the basic level, we can ask ourselves, how do we apply the basic rules of functions here? What is, for example, f of -4? And we simply look at -4. We're here, and that's obviously -8. What about f of 0? This is 0, and we have 4. What about f of 1? As I mentioned, this is not f of 1, but this is, so this is 10. Similarly, f of 3 is 6, and f of 10 is undefined. Same applies for f of 11 or f of -7, for example. So we actually read the value of the function in exactly the same way as we read it in any other kind of function. There is a slight difference, however. If, for example, we want to solve f of x equals -11, what's the value of x? In this case, we look at the y-axis where y is -11, and we go across, and then we go down, and we find that it's -5. So this implies that x equals -5. And so far, this is exactly what we have seen before in other types of functions. What about f of x equals -2? The same applies here. We go to y equals -2, and we find that x is also equal to -2. How about f of x equals 7? We look at y equals 7, we go across. We don't take this point because it's not part of the line. Go across to this point, and it's obviously 2.5. What about f of x equals 4? Obviously we have a 0, but then we have another value here. So f of x equals 4 implies that we have two solutions, x equals 0 or x equals 4. Let's look at another example. Let's calculate f of 10, for example. We have to look at 10, at x equals 10, and go up to meet the curve. But obviously, we don't have a curve, but we have an arrow indicating that curve continues in this direction. So f of 10 would be going across, that's 30. Now, let's use this curve to solve f of x equals 2. X equals 2, at y equals 2, I mean, x equals -1. What about f of x equals 6? Looking across from where y equals 6, we have no solution. F of x equals 7. Cross, again, no solution. And f of x equals 1. We have probably -1.5. And f of x equals 10 gives us x equals 4. So that's as far as the curve is concerned. How do we express this kind of function? The notation that we use is to say that f of x is equal to, and we open a curly bracket, and we say that for the first part, f of x is equal to 2x plus 3, where x is less than 1. And for the second part of the domain, it equals 5x minus 2, where x is greater than or equal to 1. So this tells me that there are two rules. One for the first part of the domain, and the other for the second part of the domain. So how would I calculate, for example, f of -4? Obviously, x equals -4, and -4 is less than 1. Therefore, I use this rule. So this equals 2 times -4 plus 3 equals -5. How about f of 0? 0 is still less than 1, and I apply this rule, so it's 3. How about f of 1? 1 is not less than 1. It is greater than or equal to 1, so we have to apply this rule. F of 1 is also 3. And finally, f of 3. 3 is greater than 1, so we apply this rule. 3 times 5 is 15, minus 2 is 13. In this case, if we consider the domain, it is divided into two parts. Where x equals 1, the first rule applies for values of x that are less than 1, and for the second part, it applies for values of x greater than or equal to 1. Therefore, the domain of this function is such that x belongs to the set of real numbers. How about looking at this curve? How about calculating f of x equals 4? We are now trying to solve algebraically. We're not finding the value of the function. We want to solve f of x equals 4. What we need to do here is to say, okay, we have two possibilities. 2x plus 3 equals 4. That's the first rule. We solve 2x by subtracting 3 from both sides equals 1. X equals a half. Now we need to check. We use this rule which is applicable for values of x that are less than 1. And we got a value of x that is a half, which is less than 1. So yes, that's a solution. We still need to try the second part. 5x minus 2 equals 4 gives me 5x equals 6 and x equals 6 over 5. Now 6 over 5 is greater than 1, and this rule was the rule used for x greater than 1, so yes, this is another acceptable answer. So in this case, f of x equals 4 has two solutions. If on the other hand we want to solve f of x equals 8, we do the same. 2x plus 3 equals 8 gives me 2x equals 5, giving me x equals 2.5. But this rule applies only for values of x that are less than 1, and this gives me a value of x that is 2.5, so this is rejected. But still, I apply it for the other rule. 5x minus 2 equals 8 gives me 5x equals 10 and x equals 2, but this rule applies for values of x that are greater than or equal to 1, which is applicable to 2, so yes, this is the only answer in this case. Now, keep in mind that a piecewise function doesn't have to be made up of two linear parts. The two linear parts may be, the two parts may be linear and a quadratic and irrational and a quadratic. It doesn't really matter what, as long as there are two different rules for two different parts of the domain. And the final point that we want to mention is how to sketch a piecewise function. If I have this kind of function, f of x equals x plus 3 for values of x that are less than 1, and 2x minus 2 for values of x that are greater than or equal to 1. I can sketch the usual way. Let's say I want to sketch x plus 3. We know that it has an intercept at 3 and a slope of 1. So this is the sketch of this part. But the rule says that this is applicable for values of x that are less than 1, which means that this is not part of the curve of the function. So I simply remove it. And since it ends at 1 but does not include it, I put an empty circle here. Now for 2x minus 2, I have an intercept of negative 2 and a slope of 2. So this is my straight line. Doesn't look very straight. And it starts at 1, x equals 1 from here onwards. So I need to remove this part that is not included. But since 1 is included, I need to indicate it by a closed circle. Look at the curve. The domain is obviously a set of real numbers, and it passes the vertical line test, so it is a function.